Evaluate the integral sine squared x dx. Alright, that's a challenge. And that's something we do very often, and you need to learn how to do this. You see, we don't have sine squared x. We don't have a cos x to serve as our du. So what do? Can you write it as sine x times sine x? No, we can't, because sine x cannot be changed into cosine x easily. Well, this is where the double angle identity comes. We need to change the sine squared x using cos of 2x. Now, do you have a cos of 2x using sine squared x? Yes, we have. Cos of 2x is 1 minus 2 sine squared x. That's right. So we use that identity. Use the double angle identity to rewrite sine squared x as, look at this, cos of 2x is 1 minus 2 sine squared x. Therefore, solve sine squared x from here. It will be 2 sine squared x equal to, if you take this to the other side, it will become positive. 2 sine squared x equal to 1 minus cos 2x. No problem there? And therefore, what is sine squared x? Divide both sides by 2. You get sine squared x is 1 minus cos 2x all divided by 2. Sine squared x is 1 minus cos 2x all over 2. And this can be integrated. Is that right? Yes, it can be. We will see. We have done this before. So, now your sine squared x become 1 minus cos 2x divided by 2. So, anytime you want to integrate sine squared x, you need to change it into this form. Alright, let me ask you. Can we use the same method to integrate sine to the power of 4x? Yes, we can. Because if sine squared x is this, then sine to the power of 4x is raised this to the power of 2, and then expand and simplify. We can integrate that. Okay, let's do this now here. Replace sine squared x by 1 minus cos 2x over 2. So integral sine squared x is integral 1 minus cos 2x all over 2 dx. And 1/2 comes out. You see, this over 2 is a 1/2. That is 1/2 times 1 minus cos 2x dx. Alright, can you integrate this? I'm sure you can. Integral of 1 dx is x. What is integral of cos 2x dx? Well, we talked about it several times. Integral sine ax is negative cos ax divided by a. Integral cos ax is sine ax divided by a. Integral cos 2x is sine 2x divided by 2. Integral cos 5x is sine 5x divided by 5, and so on. So we can integrate that. That is 1/2 times integral 1 dx is x, minus integral cos 2x dx is sine 2x divided by 2, plus c. And that will be, if you take 2 as the common denominator here and factor it out, it will become 1/4, then x will get multiplied by 2. 1/4 times 2x minus sine 2x plus c is the answer. A very important skill. You need to remember that and practice it. Alright, how about this? Evaluate the integral. Integral cos squared 3x dx. You see, the 3x really doesn't matter. That's not going to make any difference. But it is the cos squared form that you need to take care of. What we did just now is a sine squared form. We changed the sine squared x in terms of cos of 2x? Can you change a co-squared form in terms of cos of 2x? Yes, you can, because cos of 2x has got 3 forms. Now, how many of you recall the 3 forms of cos 2x? Cos 2x is cos squared x minus sine squared x. Then 2 cos squared x minus 1, also equal to 1 minus 2 sine squared x. Well, so we are going to use that over here. Well, before going into that, let's deal with the 3x, although it is not very important. So let's substitute 3x equal to u so that it becomes a single quantity. If 3x equal to u, 3 dx equal to du, or dx equal to du over 3. So what does this integral now become? It become integral cos squared 3x dx become integral cos squared u du over 3. See, the 3x has been replaced by u and dx is du over 3. And the 1/3 comes out, so it will be 1/3 cos squared u du. And now this is the time you need to change that cos squared u in terms of cos of 2u by doing this. Cos of 2x is 2 cos squared x minus 1. Therefore, 2 cos squared x equal to cos of 2x plus 1, or 1 plus cos 2x, and therefore cos squared x equal to 1 plus cos 2x all divided by 2. So cos squared x is 1 plus cos of 2x divided by 2. Now, if cos squared x is 1 plus cos of 2x divided by 2, what is cos squared u? It will be 1 plus cos of 2u divided by 2. So let's write cos squared u in terms of cos of 2u. So integral 1/3 integral cos squared u du is 1/3. Cos squared u is 1 plus cos 2u over 2 du. And the 2 can be taken out. It will become 1/6 integral 1 plus cos 2u du. Can you now integrate each of these? Integral 1 du is u. What's integral cos 2u du? Integral of cos 2u du is sine 2u divided by 2. Don't forget that. So that will be integral u du is u plus sine 2u divided by 2 plus c. Why have I colored these u's? Because our substitution is u equal to 3x. We need to bring that back here. So bring that u back. It will become 1/6. U is 3x. So when u is replaced by 3x here, it will become sine of 3x. It will be sine of 3x times 2 is 6x over 2. And that will be, take 2 as the common denominator here. When 2 is taken as the common denominator, 2 will get multiplied here, making a 6x. And take that 2 outside, it will become 1/12 6x plus sine 6x plus c is the answer. Okay, let's try another one. Oh, this is good. Integral secant squared 2x minus 1 dx. All right, tell me, what is integral of secant squared u du? Integral secant squared u du is tan u plus c, because the derivative of tan u is secant squared u. So all we need to do here is make a substitution, 2x minus 1 equal to u. So 2x minus 1 equal to u. That gives me, take the differential here, 2 dx equal to du or dx equal to du divided by 2. So what does that integral become? Integral secant squared 2x minus 1 dx become 2x minus 1 is now going to become u. That is integral secant squared u du over 2. And now the 1/2 comes out. That will be 1/2 secant squared u du. And what is integral secant squared du? It is tan u. So that will be 1/2 tan u plus e. And now replace your u. That is 2x minus 1. So the result is 1/2 tan 2x minus 1 plus c. A very simple integral. Another one. Evaluate the integral